Okay, moving on, ladies and gentlemen. Let's welcome our next speaker, talking not so much about culture, but more about data, one of the big words in modern technology. Alec Gardner is the Global Head of Advanced Analytics and a spokesman at Teradata Corporation.
Hello, everybody. Hi, everybody. Assalamu alaikum. Thank you for having me here. I'm going to talk about data and putting data to use. This is the agenda I have for you today. I'll briefly touch on the concept of being data-driven and a guiding principle about what that means. As a leader in your organization, you make decisions, and the data in your organization can inform and improve that decision-making process. Then I'm going to talk through a vision of a sentient enterprise, where the organization has capabilities and principles that enable it to gather new data, understand it, the value of it, and where appropriate, listen and respond to the signals that come within those data triggers. I'll then cover 4 things that leaders need to consider to enable this vision. And then in this presentation, I will talk about the often enigmatic, flying unicorn-esque persona of the data scientist. A role so revered that surely everyone wants to be one. In this room, there are surely some of the finest minds in the country, so I'm sure we have some candidates for it. I used to be a maths teacher, so I'm going to give you a little bit of a test. It's been well advertised and presented that a data scientist, someone who can take a rigorous scientific research-based approach to data and analytics and uncover exciting new opportunities from it, is key in enabling the role, enabling business change in a modern digital economy. So, if the rest of my presentation I've described doesn't excite you that much, then I've got a little teaser for you. I've got a little test that'll keep your brain ticking while I chat about those other things. So here's a test. Could you be a data scientist? This is a quiz. It's from a game show. I'm going to take on the persona now of a game show host, and I'll come to the answer for this at the end. So suppose you're on a game show. I want to see how you think. I want to see if you think differently about numbers, about data and analytics, okay? Suppose you're on a game show and you're given the choice of 3 doors. Behind one door is a car, and behind the others, goats. Now, I'm going to assume that you want to win the car. Now, I live in Australia currently. I'm a venerable barbecuer, so you know I can make use of a goat as well. I can make some good food off that, but I want the car, right? So let's assume you want to win the car. You pick a door, and then the host of the game show, who knows what's behind the doors, opens another door which has a goat. Then he says to you, "Do you want to switch?" So what would you do, and does it matter? So I'll come back to that right at the end, but in the meantime, as I say, I'll talk about this concept of becoming data-driven and this vision of a sentient enterprise. I will go very quickly now because of the time constraints that we have. So if you are tempted to take pictures and you miss things, then please come and ask me. I can send these slides to you and discuss things further. Okay, so one of our main ideas is that we're working in a new economy where being data-driven is essential to survival. Just as the internet created a new economy of e-commerce, we're seeing the creation of a data-driven economy. Data equates to an asset, and companies that know how to utilize that data are leading the way and becoming more competitive and providing better services. Common business models are being digitized. Advertising, books, music, news, maps, and new product enhancements are completely upending traditional business models. We're seeing self-driving cars, e-commerce, transportation sensors, and as was touched on before, in particular, high-tech medicine. Business models are also being redefined as products come out that are based entirely on data. LinkedIn, eBay, et cetera, these increasingly arrive and data for sale becomes possible. Data-driven businesses have what it takes to lead the way in their industries, such as data-driven retail, data-driven manufacturing, and also data-driven government, for those of you in the public sector. Another phenomena is the change in the economy is the relentless increase in instrumentation, the much vaunted Internet of Things. As more and more businesses adopt the Internet of Things, the data stream that began with big data has now become a data deluge, because every device is talking and it just doesn't stop. It's just going to get more and more chatty. And the data from the product is now a core asset in the organization, and it's changing everything. Previously, products were designed in discrete generations and versions. The norm now is continuous design, continuous feedback. Previously, we had siloed machines and manual error-prone processes. Today, data transcends those different processes to lead to fully automated networked and systems. Many companies are offering their products as services. Their support services are improving because of the digitization of those products and services and the continuous feedback that they get, so they can start to predict challenges therein and predict failure. So a guiding principle around data-driven to take away is this: grasp your data and give it a voice, a seat at your decision-making table. This lets you make better informed decisions, and in some cases you will be able to automate those processes and those decisions. And many of you will be able to hand some processes over to systems. That frees up your people and yourself to add value where you can, where the human still beats the machine, because there are many scenarios where human perception, human realization does still override and improve on even the most heavy processing machines. It doesn't mean that machines are taking over. Rather, it means they are utilized in the right manner, and they can take over some tasks and improve service delivery and performance. And that's what I'll cover in this next section. As we go through, the consideration for a leader as we go through this process of how data transforms business, think of the leadership principles of experimentation, collaboration, and then automation as we go through. So the sentient enterprise is this concept. It was founded by Oliver Ratzesberger, who's the president of Teradata Labs, and Professor Mohan Sawhney from the Kellogg School of Management. And I'm going to go through this very quickly. So you can go and research. It's this idea that the organization becomes connected. As that data grows, that I've covered before, the systems talk to each other, but how do you actually enable improvement? How do you capture that data, and how do you understand? How do you share insight between each other? How do you search and find new pieces? How do you improve analysis? So as I say, there are five stages that we see on this step. The first is to release your data, to make it available. And this is where those data scientists come in. So those of you who already know the answer, well done, we can have a look at this particular piece. Get this data and build hypotheses about its understanding and quickly test it. And that leads us into experimentation, which is the essence of data science. It's the scientific aspect to data. So typically these people are researchers. They understand how to ask new questions. They understand how to test a hypothesis very quickly. That's the agile part of it. But the science part is really important. You have to understand the purpose of your experiment and then the ability to deploy it at the end. So we like to say that all science is data science. Not all data is science. Don't be confused about just capturing data and thinking that the rudimentary analysis will work. You have to be able to start to test some hypotheses if you're really going to be able to take these analytics and deploy them for service improvement. And the data that presents this great opportunity to be able to come increasingly automated and increasing service improvement is looking at what we call behavioral data. So typically we've understood what a transaction is. We've gathered transactional data. I buy something. I post something. I answer a question and give you a result. That's transactional data, very easy to understand. The growth now, because of the instrumentation in particular, because of the digitization of communication and delivery channels, gives us interaction data. What happened in between these transactions? What did I say? What did I try? What did I mean? What did I think as I was going through these transactions? And behavioral data from these digital sources increases the data volume by tens to hundreds of times over. But it gives you a lot more opportunity to understand behavior. And if you can cluster people by behavior, then you can better service them. We start to understand that there are some customers that are driven by product. They're very loyal to your product. There are some customers that are driven by service. That's understandable, but there are two very distinct categories within that service preference. There's those that like a personal service and those that like a fast service. And they're very different, and you should treat them very differently when you engage with them and when you provide services to them. So for example, and taking this data and then getting analytics off it and then being able to share those to the different parts of your organization back to where you develop new products and you consider new services, research and development, product development, not talking to marketing and to sales. You need to be able to collaborate across your organization in how you use data, what that data's for, where it was effective, and how these analytic processes can be deployed. So this idea of collaboration, encouraging a social environment around your analytics, around your data analysis, and getting a team together that can bounce off each other. The most successful project I've seen in the last 2 years was in one of our banking clients where somebody who'd worked in front-end customer engagement and customer marketing and had done analytics in that space moved into HR. And he took all of the analytics that we do in customer, next best offer. These are the things that you see, the customer journey, customer classifications, and he applied it internally in his organization, which relates to what we heard before. Understanding who in your organization relates to who's at risk, what can we see happening inside, and then also how can we help people through their careers, how can we maintain the relationship with them as employees. Getting analytics across different divisions is really important. And then starting to develop those into applications that can be easily consumed. And then organizations start trading on data, like I said, and they start sharing these applications and making data and analytics available. We see a lot of collaboration between the public and the private sector. We also see a lot of collaboration between different types of commercial organizations as well, where they're sharing data and they're providing these applications that take an input and provide an analytical result. That leads you all the way through to this idea of autonomous decisioning. So we see analytics embedded in business process, in service delivery. Someone comes in to engage with us. How can we see who that person is, what their preferences are, and who best do we have to engage with them, if it's a person at all? Do we automate that service? How can we better inform and target frontline staff in social services, for example, and things like that? And it's about taking the data work that we do and flipping it round. So far too often, people who work with data inside organizations play with that data all the time and have to muck around with it and transform it, and it takes a huge amount of their time. What we want to do is flip it round so that they are monitoring and making decisions off that data. So the machine starts to process what it can at scale, and then the humans make the decisions. So that's the path, that's the journey of autonomous decisioning. Not all analytic decisions go through that process. Not everything goes to that end. But you automate what you can, which enables you to use your people in the best way possible. And we get a huge amount more data from all kinds of new digital sources. So as a leader, what do we want to sort of consider around enabling that sort of process where it's appropriate? So there's 4 things. So the first one, as I said, is have that willingness to experiment constantly and adopt a fail fast, succeed sooner mentality. In too many organizations, if a project doesn't quite hit the target it went for, we don't change tack. We don't reevaluate it and we don't change it. We put it down in the bucket of failure. And in the world of analytics, you will generate many, many hypotheses as these new data streams come in, and they won't all be correct. They won't all work. So you need to adopt this fail fast process. Now the enemy of fail fast, or the opposite of fail fast, is not succeed slowly. The enemy of fail fast is fail slowly. Because you will fail sometimes. You want to make sure that you do it quickly, and experimentation will lead to that understanding and being able to adjust quickly. As we said, take new data sets. Bring new data sets in. I've had a lot of conversations in the last week whilst I've been here about understanding context. So I have a client, they're going through this process, they're in this situation, they've had this event, what was the context of it? And here are 2 classic examples of where new data was brought in and utilized. The first one is the Google flu trends, where they took new data and they didn't take any other context with it. So they thought they had this fantastic model that predicted flu, and realistically all it predicted was winter. because lots of people get flu in winter, right? It didn't take into consideration any of the existing data and analytics. On the right-hand side, this is predicting house prices and house price moves. It took all of the existing standard data that was around, and then a lot more of the market data and a lot more of the digital data, and was phenomenally successful and outperformed, these models outperformed most of the expert market opinion. So go beyond traditional enterprise data management and start to encourage people to collaborate across different divisions. And if you're in the government, across different government departments. It's one of the toughest areas to do. There are often legislative reasons why data sits within certain departments, but the more you can share across different departments, the more you can create a holistic support network for the citizens. So start to understand that method of collaboration and deploy it. And then, as I said again, about developing a rigor around automation that enables business change and capitalizes on human intellect. You'll hear a lot about artificial intelligence, machine learning, et cetera, These absolutely have their place, and we're providing great success where they can be used. So let's flip it and use them where we can, but allow the humans to make the decisions as well, and have the human in the piece. Because as I say, there are certain scenarios where humans can spot patterns. In fact, there are more scenarios where humans can than machines can still spot patterns and make decisions in the absolute. So we've got to try and flip that and enable that. Have that trust of automation and deployment where it goes in. So to close, there's this piece about getting in the game, and you're going to hear about digitization in the next presentations and the next session. But it's not a great equalizer that drives all companies towards similar processes and outcomes. Instead, it's driving the leaders and the laggards further apart. So organizations that do capture data, do capture their digital, their interaction data, their behavior data, they are pulling further away and providing significantly better services than their competitors. And these, the people that quoted this, they're the people that did that model about the house prices that as I say, outshone all of the others. So just to cover on some of the areas where you can use these new data types and new types of analytics. And I needed the roving mic, because I do actually run around a lot, and I feel very sorry for you guys over there. I wanted to come over and when I did the test results, come over and stand and look at all you lot to make sure you've been paying attention. But you know, we look at this idea of digital journey and path analysis. So increasingly things are digitized. People are very competent at using their mobile phones in particular. So what's that digital journey? Where did they go? How did they get serviced? And working through that. Social and sentiment analysis. What are clients saying about you? Even in the government sphere as well. What is the public saying about the government and its services? Search and text analytics. What are people looking for? How can we improve that? How can we provide the service faster and more effectively? Network and graph analysis are how people and processes relate to each other. And I see the big Netflix sign outside. I don't know how many of you are big fans of the Game of Thrones. But if you search for Game of Thrones and Teradata, then you'll see where we built a network around the Game of Thrones connections and who was related to who. And then we applied a predictive model across it to predict who was going to die next. Because everybody dies, right? But it actually predicted it incredibly well. So if you had a look at that, it's a great explanation in an interesting and easy to consume medium of how analytics at scale and then the mix of different types of analytics can provide phenomenal insight, even on a work of fiction. And then it also talks about how some analytics have a lifespan. In fact, most analytics have a lifespan. So the model that we used first, that predicted the extreme event at the end of season 1, for those of you who do know the story, by the end of season 5, because too many people have died, we have to use a different type of model in order to keep the predictive capability up. But I digress somewhat, because that's quite a good one. And then longitudinal path analysis. So where these have all come from, a lot of these have been led and innovated in the commercial sector. I do want to call out that we have a lot of momentum in the public sector as well. So we talk about healthcare, where we've done the network and graph analysis, sort of comorbidities for treatments, the path and journey analysis. We look at cancer treatment care. A lot of the clustering algorithms that we use, again, look at the sort of the treatments and medical treatments. And in particular, this longitudinal path analysis, we look at a longitudinal survey of people as they move in and out of risk through the social provisions and the social networks, the social services that are there. And we work, as I say, in a lot of private and public partnerships with the governments in terms of providing this sort of analytics, and also with the universities. And that includes in developing new courses around data science and around advanced analytics. And we're doing that here as well, helping the universities develop these data science courses where you understand the applicability of these in all different kinds of scenarios, so that we get the next generation ready for this challenge. So that's where I finish, except for the test. So I'll come back to you. So those of you that maybe did have a break, it's time to come back and have a look at the answer. So here we go through. So could you be a data scientist? It's kind of a bit of an unusual question, but it does see if you think differently. Okay, suppose you're on a game show and you're given the choice of 3 doors. Behind one door is a car, behind the other is goats. You pick a door, say number 1. Okay. Most people, I would hope everybody, knows the probability of winning at this point, right? Okay. So you pick number 1, there's your probability of winning. Okay, but the host, who knows what's behind the doors, opens another door to show you a goat. Number 3. He opens number 3, which has a goat. And then he says to you, do you want to switch? So what would you do, and does it matter? Hands up, who would switch? I knew we had some of the brightest brains in the room, but even then, it's well under half. I'm sure some of you are, if I asked then who would not switch, the rest of you should put your hand up, but I have a feeling that not all of you would. But I mean, you can see, it seems like a trick question, and you should switch. You absolutely should switch. I used to be a maths teacher, I did tell you that at the beginning. Do you believe me that you should switch? Yeah, you believe me? Usually I have to convince people, right? I have to go through the proof of my hypothesis, which again is an important part of data science. But you believe me because I said I was a maths teacher. That's excellent. There's a lot of respect in the room. I like that. So I'm going to explain it to you, right? I'm going to take you through the scenario that makes sense of this, because there's one really important piece of information on that page that the right kind of brain, the right kind of mindset that constantly questions things will spot. And it's that the host knows where the car is. That's what's important, okay? So here's the scenario, right? Say you picked the car. If you switched, I'm afraid you lost. That's true. So you would lose. There are scenarios where you lose. It's not a done game. It's not a. Now let's just move through. Pretend you picked the other ones. Okay. If you picked goat A, the host must reveal goat B because he's going to show you a goat, right? So switching wins. There's another scenario where you pick door C, right? And the host has to show you goat B because he has to show you a goat. And switching wins again. So there's 3 scenarios. 3 scenarios, and in 2 of those scenarios you win, in 1 you lose if you switch. So you should always switch. It's part of Bayesian, and it's part of Bayesian theory. It's about the posterior. This idea, it's called the Monty Hall problem because that's the game show. And a mathematician called Marilyn Vos Savant was the one that came up with it. And there's huge debate about it, even now. I can present this at conferences. I hope it doesn't happen because I saw the level of respect in the room about how much of you believe me. But we do get people come up with a question at the end. But that's the scenario. It is that important piece of information that a host knew. It wouldn't be much of a game show if he went, do you want, I'll now show you a car, do you want to switch? That wouldn't make sense, right? He knows where the car is and he shows you it. And that's the type of brain we look for. So I hope that was entertaining. I hope that was interesting. I know it was fast to go through that main bit. But again, thank you very much for your time.
Thanks you very much again, Alec Gardner. And Alec brought up at the end, I'm glad you didn't touch on personal data, because that would just got too ugly, really, wouldn't it?